We are recording this so that we are able to put this up on our website so that everybody else can see what they missed today. We also have with us Alex Eden, who is our graduate fellow. We have Trent Smith from NASA's Kennedy Space Center and Dr. Joya Massa from Kennedy as well. So our project scientists. We also have with us a special guest, Daniel Bernal, who is works with our external evaluator from M&N Associates. And he's going to join us today because he's going to be talking a little bit about data visualization. He has a short little presentation for everybody. So I appreciate everybody joining us today. Thank you so much for coming. And if you can, make sure that you are muted. So that perfect. But if you have any questions, because it's such a small group, feel free to unmute yourself. Feel free to put a message in the chat, and then we can be able to answer it or give you any information that you're interested in. We're going to try to keep this to an hour or less, and that's where we are right now. So thank you everybody for coming. Before we got online, Trent Smith and Trent and Joya were talking a little bit about upcoming experiments and things, and I just wanted to give them an opportunity to chat a little bit about what they're currently working on and what's on the horizon. So Joya, Trent, it's up to you.
Joy, do you want to talk about your plant torture experiment?
Yeah, I'll talk about that. So we are currently growing plants on the International Space Station. I've talked about this in the previous chats with the scientists, but it's been a while. So this is an experiment in advanced plant habitat called PH07. We're very creative with our naming. So this is an experiment with the lettuce, with the red romaine lettuce, and we are looking at different moisture levels in this lettuce. So instead of waiting for water stress to happen, we're intentionally water stressing these plants out. So this is 3 28-day grow outs of lettuce. So you guys, are often doing, 1 grow out or 2 grow outs during your semester. So we actually have the astronauts doing 3 grow outs. And we started the first one in early December. Yep. Hi, Emma. I think you have an open mic. So we started.
Oh, Joy, you got muted on that one.
Sorry about that. So we had the first one started in early December, and we harvested those plants right after Christmas. And then we started the next one on New Year's Eve, or right around there, and harvested those plants at the end of January. And then we started the last grow out last week on the 11th. The first 2 sets grew pretty well. The first set grew really well. The second set was a little delayed, but they grew okay. This third set, it was a slightly different batch of seeds. We had sanitized the seeds in different batches, and they just don't seem quite as vigorous. So the plants are growing pretty slow, but I'll show you if I can share. Let's see. I can share the photos from today. And so these were our little baby plants from today.
Oh,
so
man.
You can see that they're a little behind where they should be. They're about 9 days old today, and they're looking more like 5-day-old plants. Some of them, like this guy here, he's doing pretty well, but some of them are really small. So what we've got in here, this is the advanced plant habitat. This is from the top camera, and this is what we call a science carrier. It's a tray, and we have 4 different quadrants, and so we actually will subject these to different moisture levels. So this one will actually be the control quadrant. We haven't started most of the moisture treatments yet, but this one will be held at control conditions, so like optimal water. This one will be held flooded. This one will be held at a drought condition, like just enough water to keep them alive. And this one will be at control conditions until we're pretty big, maybe 15, 16 days old. maybe a little longer because we're so delayed. And then we're going to shut the water off and let the plants pull the water down naturally until they wilt. Then we'll add water back to control conditions in this one. And then we're going to let them dry down again. And so we want to see how these different watering treatments impact the plant growth, but also their microbiology, their microbial ecosystem. So just an example of what the other camera in APH looks like. This is our side view camera. So we have a camera from the side, and so you can kind of zoom in and see our little plants there. So today we had to put together a message for the astronauts because tomorrow morning at 5:30 in the morning, they're going to be thinning the extra plants out. So we had to tell them, keep this one, take out this one and this one, keep this one, take out this one. So we put colored dots on the plants that we want them to keep, and then selected which ones that they will remove. So tomorrow they'll go and they'll thin out these extra plants just like you all did, and they'll put those in the freezer for us, and then the other plants will continue to grow. So that's what's going on Space Station, and we have started our ground control experiment as well for this that's going on in our chamber here at Kennedy Space Center. So that's my update. And I think Trent can talk a bit more about future plans.
So the other update that we have is we are funded at least for 1 year, with the possibility of being funded for 3 years, to screen a number of crops, just like you all are doing. And we're actually planning on screening the GBE crops from CRL2 up to a 6. And so we're looking at some of the short duration crops, the herbs and leafy greens, things like that. And we're going to also test some longer duration crops. So I think some of the crops Amy and team were looking at are some of the Mysomes. I put ice plant on there because why not? We're looking at the amaranth, purslane, fernleaf dill made it. Yeah, there you go. CRL. Thank you. Lemon basil's on the list. Dark purple opal. The nasturtium. I can never say it right. Empress of India. Yeah, GBE 55. I can say that. We got Lizette, lemon balm, and Thai basil. We got more to add, but those are the ones we're looking at. So we're really excited. Space Biology is funding us to advance the crops, screen the crops, just like you all are doing, to get a number of crops ready. So that way, if we wanted to grow them in veggie or APH or the next generation crop system, and it's ready for science verification test and growth on the space station.
That's really cool. So just so you everybody knows that we recently went through all of the plants that have ever been tested on GBE, and we looked at them based on the data that the students have collected to determine whether they've sort of passed this sort of technical readiness level 1, a crop readiness level 1, or and if they were at a crop readiness level 2, and that's basically, did they grow well, did they produce well, did they germinate well, and all of those things to determine. So we went through all 230 some plants to determine which ones were good to move on to this second level. And so that's what Trent is talking about, how those plants got from all of these like weird trials that we've done of all these varieties over the 10 years we've been doing this project. And now these are the ones that are going to move on and be tested further. So that also allows us to be able to help determine what we're going to be trying next year. So even the things that here it is. So even the things that we've already tested, maybe we tested on an old system with an old protocol. Maybe we want to try them again in our new system with our new protocol. So that's how we went through each and every one of these of plants that we've tested before. So you can see this on the list that Trent is showing.
And it's probably worth mentioning, I'm going to be reviewing this report that you're seeing appendix on right now tomorrow with our advanced food scientist to see if I can get concurrence, and hopefully we'll publish this 80-page report in March. I'm going to call it March.
Fantastic. That's exciting. That's really exciting. And so now you can see how much your data is really impacting the research that NASA is doing. So this report came from, your data for whether it passed through the crop readiness level 1 and crop readiness level 2. So this is really exciting that you're starting to be able to see the real fruits of your labor. And the new trials that we do for the coming year will be based on what we learned from the past years and what we learned from this report and the experiments that NASA is considering to do during the next upcoming trials in their lab and on spacecraft, right? Awesome.
Yep. So that's so you saw the crop readiness level testing that I think Joya shared with you. So that gets us to that level, and then we keep moving on till it's grown and eaten in space.
Exciting. Does anybody have any questions for Joya or Trent? You can unmute yourself, ask a question. You can type it in the chat. So I do have a question for Joya. How did you determine the plant variety that you were going to use in your drought tolerance test?
Yes, a good question. We've used this one a lot. This has sort of been the very first one that we grew and tested in veggie is GBC1, I think, on our list. So we've got a lot of Growing Beyond Earth data on it. We grew it in both Veg01 and Veg03 experiments. And it's just been a really reliable plant from a lot of different perspectives. So yeah, the outrageous red romaine lettuce. It's kind of nice because it's a red-green lettuce. And so it really shows stress very well because it's normally kind of red with green with red, on the leaves. When it gets stressed, the leaves turn all red and they get darker red and they get more compact. And so we'd seen some of these this morphology, the way this looks, and decided, wow, this is a nice kind of biological indicator for stress. So we did a lot of pre-flight testing for this experiment, but because we had so much data on this type of lettuce, we know how to grow it pretty well. Dr. Matthew Mickens in our group had done a lot of work on LED lighting for this plant, and he had a very good light recipe as well. So we were working with our baseline data. And when you write a new proposal, that's what you do. That's what you all did when you proposed new projects for the spring semester. You worked with what you knew, starting with your fall semester work, and then you changed, a variable. And so it's the same idea for us. We start with something that we know, and then we go to the next step. So we wanted to take the next step with this lettuce. We had a lot of uncontrolled water stress, but we really wanted to see how the plants responded to this intentional water stress, with the idea that once we can learn about this, we can help define, the best watering conditions moving forward in terms of, if you're going to have a failure, what's a good way to fail? Is it better to fail by too much water? Is it better to fail by not enough? And when I say better, what I mean is for the entire ecosystem. So not just the plants you're growing now, but the plants that will grow next. They're going to be impacted by the microbes from the plants that are growing right now. And so we want to understand how this will impact future plants and this whole ecosystem. So that's a lot of the reasoning that were behind this.
That's very cool. That's very cool. The folks from Waterloo Secondary School wanted to let you know, Trent, that Amaranth is a really good choice, flowering in 49 days. And they are hoping that this can be used in the future and used as a substrate in a future food printer. So that's pretty cool. I don't know a lot about a food printer, but I think that's kind of cool. Can you explain that just a little bit, what that means? Folks from Waterloo? Okay.
Hey, Joya, didn't NASA check out a food printer a few years ago?
Yeah, I think so. So, the idea was something like a 3D printer, but for food. I believe they were looking at something that, could print from raw ingredients like flour and tomato sauce and things like that. So you can actually imagine something like a pizza would be printed pretty well, right? You print your dough onto a platform that then bakes it, and then you print your next layer and your next layer. So it's a really interesting concept. I know they have 3D printers for things like frosting for cakes to make some really amazing decorations. And so, yeah, there's a lot of potential with these types of additive manufacturing technologies maybe being considered for food, but especially for something flat and plainer like pizza or lasagna, you can really imagine that it would work well. Not sure about using plants as substrate, but I think there might be some neat possibilities there.
That's very cool. Thanks for sharing, Waterloo. Appreciate that. Um, awesome. 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 All right. Any other update? Any other questions for the NASA folks, Joya and Trent? Anything you want to ask? All right. Well, feel free to add your questions into the chat so that we can make sure that we don't keep you guys too long, but please add any questions that you have for us. And if you think of questions after the fact, send them to me or to the GBE team at gbe@fairchildgarden.org, and then we can make sure that we try to work to find those answers for you. Appreciate it. All right. All right. So the other piece of today's conversation is to talk about data visualization. So as we start to prepare, so we know that April 12th is the day of the symposium. So April 12th, we are hosting the in-person and virtual seminars or symposiums on the same day. Brianna, do you remember what was the date that the proposals are due? We wrote that down. Some that we're gonna.
It was March 4th, I believe.
Yeah. Okay. We will
March
be
7th, sorry.
we will be updating our website with the date for proposals to be not proposals. Registration for that symposium. We need to know in advance if you're planning on presenting, if you're planning on being here in Miami, or if you're planning on being in the virtual. I'm assuming everybody that's on here right now will be at the virtual. Maybe you're going to show up in person. But letting us know so that we can schedule this out. We will send out in our next newsletter. We will be sending out all of the dates and everything to make sure that you guys are aware of when you need to register by, when you need to have your presentations to us so that we can have you in the symposium. So at the symposium, if you've never done it before, the symposium is a beautiful opportunity for you to share your trial to data and experiment with NASA scientists and administrators through a 5-minute presentation, allowing you to get feedback. It's super exciting for your students, for you to be able to present your research directly to the NASA folks to get their feedback. And the NASA folks are super excited because they get to learn gain new ideas for future experiments, and so do we. So we're excited about that as well. It's a really good opportunity. So if you haven't done it before, I very much encourage you to join us for that day. So that's April 12th. It starts the in-person as at 10 o'clock in the Eastern Standard Time, and the virtual starts at 3 o'clock Eastern Standard Time. And we have a session for people who are even farther away, like Australia and Europe, in the morning. And we'll make sure that you get all of that information. So in order to present your research, you need to be able to present your data. So your data is really important, not only to the NASA scientists and researchers, so you figure out the crop readiness levels, but also when you're doing any experiment, sharing your data is incredibly important to prove your work, to either disprove or prove your hypothesis or lead you on another direction for some other experiment that you might be interested in doing. And so what we've done is we've invited Daniel Bernal from M&N Associates to talk a little bit about data visualization, talk about how he came to this point and how he's a part of this, but how he's been using data in his life before. So I'm going to turn it over to Daniel and I'm going to let you go ahead.
Thank you, Amy. I appreciate it. And what a great segue. I'm going to share my screen here if I can. Hopefully y'all can see that very well.
Yep.
Awesome. So, as Amy said, if you are enjoying your experiments or not, you're collecting a lot of data, and what we do with that data is really important. And the reason that I love the term data storytelling is because when you think of stories, you think of a plot, you think of characters, you think of meaning, you think of drama and adventure. And I don't know that most of us associate those things with data. Unfortunately, I feel like a lot of people think of data as just numbers. And so, one of the biggest things with data storytelling is really, okay, so you have some numbers, what do you do with those? But the other part is recognizing that data comes in many forms. Data is feedback in a survey. Data is observations that you're making about different experiments or different situations. So it's really important to be able to effectively communicate about your data. Before I dive into that too much, I do want to share a little bit about me and, like Amy said, how did I get involved with data to begin with? So I graduated from Carleton College with a BA in mathematics. So I've always enjoyed math and thought about data a lot in my life. And what I did with that bachelor's degree is I went into teaching. I was a math teacher. I'm local to the Twin Cities in Minnesota. Actually, there's a school that's participating in GBE that's like a few miles away from where I live, which is really fun. This is happening in my backyard. It's so fun to be part of. But also, as an educator, I moved into data coaching. So one of the things that I am good at is looking at all of the data that someone generates, and in our case, it was data about how our students were doing in class, and saying, okay, what do we do with this? How do we communicate the bright spots? How do we communicate the challenges? How do we use data in ways that support our goals? How do we use data in ways that are true to the data and true to the people that the data is generated for or by? So that's where my career started, and I actually got a master's in learning design and technology. And learning design or design thinking is something that came from the Stanford School of Design, and it is a way to approach things in all aspects of life, or any aspect of life, with an engineering mindset, right? If we have a problem, we want to create a solution that's actually going to fit it. We need to talk to the people who are affected by that problem. We need to establish a set of parameters, and we need to be able to iterate or do an experiment or try a solution multiple times and make small tweaks. Data is a huge part of that, and especially thinking about not just the numbers of the data, but what do people feel? What are people thinking? What are people communicating that they need? So all of that kind of led me into taking my math background and going more into how humans use data. I became a nonprofit director. I was directing an education program. And so that allowed me to learn even more about how people use data in every day. And I also learned how to manage a database. So if you're someone that's collecting a lot of data, it's an important skill to know how to manipulate that data. And by manipulate, I mean like literally store it in ways that are accessible, store it in ways that you can share with people, or protect your data privacy. So there's all sorts of aspects to data, but storytelling is definitely my favorite. Uh, a few years ago, I took a certification in data visualization, and I'm such a visual person. I really learn well visually. I'm creative visually. And so the data visualization piece for me was the biggest thing that clicked around, oh, there's these really powerful tools for telling stories with our data. And so that's kind of the core of what we'll talk about today. But then also there's a field called evaluation, and that's actually how I got connected with GBE. Amy mentioned they use an external evaluator. So I'm a senior associate at MN Associates Inc. And Kavita Mitapali is the founder of that evaluation company. And what we do is we take a look at the data and the progress that different organizations are making, and we make our own judgment about that. The idea of an external evaluator is someone who doesn't have a direct interest in what is going on. So I'm not part of NASA. I'm not part of GBE. So whether or not the data looks, good or promising, isn't directly impacting me. And so it creates a level of objectivity that you can say, this is our assessment of the data. This is what we think the data shows. And if that matches what GBE is saying, great, that's wonderful. That means there's that level of self-awareness. So it's kind of a check to make sure that organizations, companies are producing data that can really be trusted, and evaluation uses data storytelling, because evaluation is basically telling other people how things are going with a project or with an organization. So that's kind of the background that I bring. I'm going to talk about a few different examples, but I want to take a step back and say, why do we talk about data storytelling? What can it do for us? I think about four main things. So providing context is very critical. Um, if you just present the numbers or the numerical data about something, people might say, "So what?" Right? Or I don't know if 90% plant growth is a incredible statistic, or is it like actually kind of a bad statistic? Do most plants grow better than that? So thinking about the benchmarks or the baselines that you're using to compare your data to is really, really important. That's an important part of the story. Complexity is also something that data storytelling is very powerful with. And we'll combine that with visual examples too. So I said I'm a visual learner. A lot of people learn very well visually, and you can communicate different things visually than you can with numbers alone. Sometimes it's really hard, especially when we're talking about really small or really big numbers, to really understand what those numbers mean. And so visualizing something can be a really great way to have people connect with that, have people really understand on a sensory level what is going on with the data that you're generating. And then finally, action. I think good data storytelling should compel people to act and should empower them to act with that data. And so, in the example of the GBE experiments, having the action be actually producing information that's valuable to astronauts growing plants in space, that's incredible. And I think it's also very inspiring. And I think good data storytelling enables people to collect their own data if they want to participate, right? It's a collaborative thing to be able to tell about our data. So we're going to hop into some of these examples. The first one is actually from a dashboard that I created as part of our work with GBE. And this was a couple of years ago. And this dashboard is made on Tableau. So we'll talk a little bit about different formats or different platforms you can use to visualize your data. But this example is heavily contextual, right? It starts off with, here's actually a map of where different schools are located for this particular year of experiments. I think this was a couple years ago. And here's that one right in my backyard in Minnesota. But you can see that this is an interactive platform. And so not only is it giving you the context of where these things are happening, you can also hover over them to get more information. So it's kind of like a table of contents if we're using a story metaphor or a book metaphor. This allows you to go at your own pace through the data and flip back and forth and be able to understand it in your own way, which is really important. You can also, with different data visualizations, use factors like color and size to be able to communicate about your data. So down here, we see that the color coding is actually corresponds to different cultivar varieties. So like Trent had showed that big list of them. These were the ones that were actually used in these experiments for this time frame. And then the size was actually one of the factors we were looking at, which was edible mass. And so the larger the size of these circles on this map, the higher the average edible mass of the plants that those schools grew was, which in our case was the goal. We want to see how can we maximize the edible mass. So this is cool. You can zoom in. You can really look into one school at a time if you want to, or you can click in on one of the cultivars to say, okay, where are the schools that were growing Finocchio fennel, which is one of the best plant names. So this is really fun. And then on this dashboard, you can also have multiple tabs or multiple pages. So we were able to communicate and tell a story through a lot of different types of charts. We have some line charts, and it's the same thing. These are all interactive, so you can isolate different data. And we looked at germination rates and the edible mass, comparing the edible and the total mass. So it's just and you can provide text, which I think is an important part of giving the context to helping people understand. So this is, I would say, a more kind of traditional way of data storytelling with a dashboard, right? It's like there's a ton of information. You can click in, it's interactive. This is quickly becoming like a standard way to do data storytelling. Another example, and I didn't start off trying to find all science-related examples, but it just kind of happened. Space-related, it just kind of happened. So this is kind of a poster type visualization. And this is someone who is using open data from the NASA Open Data Portal and Wikipedia. And they told a story and they titled it, "It Fell from the Sky." And I love this one because it's the author kind of describes like, this is something that happens all the time. And I just kind of got curious about this and started to explore. And here's some things that I found interesting. They're using data on over 34,000 meteorite impacts that are recorded. If you scroll down, you can see some of the 10 largest meteorite impacts. And so they're using that same kind of size relative factor to be able to communicate information about those meteorites. And then they even were able to do a close-up on one of these. They talked about the composition of that meteorite, the size. They use a scale comparison. So here's some of that context. They said the meteorite weighed 60 tons, which is 32 of this type of car. I'm not a car person. I don't know what kind of car that is. But that really gets at that sensory element to being able to kind of intuitively understand the data that's being presented. And then another cool one is another cool part of this is talking about when in time these meteorite impacts, not when they occurred necessarily, but when they were measured. And that's important because if you look at this chart, this starts in, I think it says -600, and then ends in 2012. But for most of that time, there's not very much recorded data on meteorites. And so you can kind of see in the 70s, they see a spike. And they said that seems to coincide with the beginning of significant studies. And so I'm not sure exactly. I'm not a meteorite scientist. I'm just sharing this as a cool example of data visualization. But that kind of thing really helps you understand the complexity behind this kind of topic, and understand why you might see some of the trends in the data that you're looking at. So this one is a really cool one, very, very nice design. This next one is one you might be familiar with. It's become more popular, especially in the last, I want to say 15 years, but it's called a bar chart race. And it's not necessarily interactive, but it is what's kind of interactive, but it's animated. And so what this is doing is you can see the timeline on the bottom from 1993 to present day or 2023. This is showing the number of detected exoplanets. And an exoplanet is a planet that is outside of our solar system, but we can detect those. We're too far away to see with our naked eye, obviously, and usually I don't think we can see them with telescopes. Correct me if I'm wrong, NASA folks in the room. But so how do we detect them? There's a lot of different ways that are used today to be able to detect them. But how did that look in 1993? These technologies and methods developed over time. So if you start this bar chart race from the beginning, you can see that the years are progressing. You can see the year changing in the corner. You can see the total number of exoplanets that we've detected rising. And you can see kind of which are the different methods that became popular across different years. You can see dramatic changes in some of those technologies and techniques. And you can see some of the new ones that are occurring at the bottom. I think my favorite non-science example of this, I saw one recently that was like, who is the best pop diva from the 90s? And they looked at album record sales over time. And it was like Lady Gaga, Beyonce, Madonna, like all not just the 90s, but starting from the 90s. And you could kind of see them competing in this kind of bar chart race. So they call it a race because it's kind of real time. You can see them, the bar charts racing each other. And you can also pause these so that you can say, okay, what was happening in 1996? What was happening when we reached the year 2002? It looks like we started detecting using this new technique. This is one of my favorites. Hard to code yourself, but there are platforms that will allow you to plug in your data and it will do it for you. And you can adjust the speed and you can adjust a whole bunch of different things on this. The last one I want to talk about is this data.nasa.gov visualization, because I think it's a really cool example of how you can prompt action with a data visualization. So this is very similar to some of the other visualizations that I've showed, but and what it is it's a visualization of all the data sets. So if we look at, I don't know if you can read, the font is a little small, but it says Earth Science 2,339. So there's 2,339 data sets in the NASA catalog that's available that are related to Earth science. There's oceans, there's land surface, atmospheric water vapor. There's just a ton of different information here. It's color coded right now by where that information comes from. But you can translate it to the different topics, and then it's color coded by topic category. But the really cool part of this is if you actually click into these squares, and the square sizes show you kind of the relative amount of different data sets, it brings you to those data sets for earth science. That's the one I clicked on. And so using data visualization to actually provide access to data is really, really cool. And being able to, instead of just do a search bar, kind of see what are the data that's most available to me? How can I visualize that and enable people or empower people to use that data in that way? So I hope I've sold you on the idea of data visualization. The next thing I want to talk about is how you can do that. So I listed 4 different platforms that I know about. I've used 3 of them extensively. And they each have really great features and some drawbacks. So I'll talk very quickly about those. Looker Studio is by Google. Allows you to use multiple data sources, pulling them all in. It allows you to hook up live data sources. So if your data changes, the data visualization will also change, not in real time, but I think you can update it every 15 minutes at the most, the quickest refresh rate. It also has privacy settings. So if your data is private or you don't want to share it until it's ready for publication, you can control those data sharing settings. It is harder to do complex graphs. So if you want to do something like the bar chart race, it can be a little tricky, but I think it gets you 90% of the type of data visualizations that you might want to use. So that's a really nice one. Tableau, obviously you saw the example that I created on Tableau. Very powerful, very professional looking. It's very excellent at compiling large data sets. So if you are looking at data from thousands of different plants, for example. Unfortunately, the free version of it is public. So if you're using the free version, you have to make sure that you are okay putting that data out there. So for something like the GBE data, that was public. We were sharing it publicly, so that's something we use Tableau for. Flourish is one that I haven't had the chance to use, but I found it recently and it looks really cool. It allows you to build a lot of different types of interactive, animated. You can do the bar chart race. You can tell that's my favorite. I keep bringing it up. It's easy to edit your data in there. You do have to pay for the platform if you want to access privacy settings or connect live data sources. But if you're working with data that you don't mind sharing with the public, and it's just kind of a one-time thing, you're not updating it live, that I think is one of the most beautiful looking tools that I see out there, and certainly looks easy to use. The asterisk being I haven't actually had a chance to dig into it very much. And finally, you can make a data visualization, even a dashboard, just using Google Sheets. A lot of people will incorporate charts, text, tables, you name it. You can kind of build your own dashboard. You can have it as a tab at the beginning of a set of data. I've seen a lot of people do that. And there's a lot of examples that you can Google search for of people using Google Sheets as a dashboarding or data visualization tool. So there's a lot of different ways you can do it. Most of them are free. There's even better ones if you have a budget for it. But it doesn't have to be very complicated for you to do an effective data visualization. I would love to hear if you have questions. And I have the chat up, but I need to find it again. There we go.
Yeah, so there are no questions. There was a comment by our folks in Trinidad and Tobago. It says NASA's impact track of asteroids 2024 year 4 under Trinidad and Tobago, North South America. Unwanted data for your impact map.
I think most people, it's unwanted data.
Oh, okay.
That's pretty funny.
Yeah. So I have a question if nobody has a question. Always have a question. So if these students are presenting a 5-slide presentation for the symposium, and they have to tell the story about their data that they collected as part of trial 2, how would you suggest to them that they use that small data pool to create something that's visually appealing? And this goes to Joya, to Trent, and to Daniel. Feel free to offer suggestions in there.
Yeah, I think my biggest tip for data visualizations, especially when you're limited in terms of like how many slides or the space you have, is to get a test audience, right? You know all of the things you're trying to communicate, but unless you try to communicate it to someone and see how it goes, you might not know how it lands. So putting something together, even if it's a simple chart or if you think it's very complicated, it's really important before you present it that you practice it with someone. And I mentioned that idea of iteration, right? Getting feedback and tweaking it until it's the best that you can make it, I think is a really important process for getting ready for a presentation.
Yeah, I couldn't agree more. Practice is always good, and you know it's very obvious when we do these symposiums, which schools have practiced and which are kind of doing it for the first time. So practice is great, because if you even talk to your parents or your classmates, your siblings, and if they don't understand it, then they'll give you feedback and can help improve your presentation. I think, a lot of us are really visual. And so I've done things in the past where I, had a lot of graphs. And then I sort of changed my focus and instead showed pictures of plants, and showed comparison pictures of plants. And I personally liked it a lot better. And I think my audience liked it a lot better too. You can just sort of zone out if you're looking at graphs over and over again, especially if they're very stagnant, so you can think about combining things, being creative, maybe have pictures of plants on your graphs instead of just, bars, and so I think, yeah, use your imagination and see what you like and what works and what doesn't get across to your audience.
Yeah, I second that. Having a visual of what the data means can be helpful. And I think one of the main things is, what story are you telling? You had a hypothesis. What is the main thing that either shows your hypothesis was wrong or right? And that should be the main focus of your data. I mean, you have a lot of data, but focus on the data that's the most important. If you really have very short time or a short number of slides, tell the story that's most important.
Yeah, remember, people are only going to remember maybe one or two things from your presentation. So what do you want them to come away with? What is that take home message? And then, like Trent says, frame your slides around that message.
Yeah, I mean, you can have the other data in there, but the focus should be, the main part of the story. Is it's too easy to try to talk about everything, and then you get lost in the data, and then you forget what your point was. So that's why slides are so helpful. They help you tell the story. And then when you practice, as Joya said, you figure out, oh, I'm not really telling the story effectively. And that's having a test audience is helpful. So those are all great, because you are telling a story, whether you know it or not.
Fantastic. Thank you guys for adding your 2 cents. And thank you, Daniel, for that great presentation. I really appreciate you
Yeah,
taking
that was fantastic, Daniel. Awesome.
Oh, good.
I learned a
I'm
lot
glad
of new stuff, man. I'm really excited. I'm going to go play on some software today.
you could get lost on some of these platforms just playing around with the different
Especially
settings.
if you got data. Yeah, man.
Yeah.
That's very cool. All right. So there is
Can
a
I answer
question.
that one question
Yeah.
that came in on the chat? So how is the data entered? Is it AI or on sheets? That's a really good question. So for platforms like Tableau, you can hand input the data, but if you're working with a lot of data, that's not usually very effective. You can upload in a spreadsheet. Or as I mentioned, a lot of different platforms allow you to link to an existing database, or if your stuff is already in like Google Spreadsheets, you can link to that type of spreadsheet. So usually not AI per se. There might be some things that prepare the data for easy visualization. But usually it's uploading a spreadsheet or connecting to a spreadsheet that exists already online.
Cool. Well, thank you very much. Yay. Any other questions for any of our guest scientists today? While I have everybody on here. All right. Well, we're coming up on an hour, so I want to thank everybody for taking their time today. Thank you, Daniel. Thank you, Joya. Thank you, Trent, for joining us. And thank you to all of you for joining us today. We will be putting this up on our website so everybody else can take a look at it if you want to refer back to it. I think that would be great. If you have any questions about what is, we're going to put out lots more information about the symposium and what's expected and sort of a template for you to use if you want for your slide presentation. But if you have any questions in the meantime, please reach out to us through the GBE email link, which is gbe@fairchildgarden.org, or reach out to me, Amy. I'm happy to answer any questions for you. But we really appreciate you taking the time today, and we want to thank you and hope you have a wonderful weekend and talk with you soon. Thanks,
Thanks,
everybody.
everyone. See you tomorrow,
Thank
Amy.
you.
See you
Thanks. Bye.
tomorrow. Joy, I hope you feel better. Okay.
Oh, I'm good. Just need sleep.
Yeah, me too. I got to get up at 4 in the morning tomorrow, so.
I'm sorry.
All right.
Bye-bye.
We'll
It's
see
for
you
a good
guys.
cause.
Yeah, it's for a good
Sleep in the
cause.
bus, right? With all those noisy kids.
Yeah, they'll be sleeping in the beginning, so it's fine. It'll be all good. It's on the way back, it gets loud.
You gonna turn
Yeah.
off the recording?
I don't have access to it. Somebody else does. Oh, wait.
Oh.
Oh, wait.